Hello, welcome to this channel. In this video you will learn about finding the derivative of sine inverse x from first principle. So this is how you can find out the derivative of sine inverse x from first principle. So for that let's consider the function b y is equal to sine inverse x. Okay, let this be equation 1, or you can write it as sine y is equal to x. Let this be equation 2. Okay, now let del x is equal to h and del y is equal to, okay, del x is equal to k and del y is equal to h be increment, small increment in x, and del y is equal to h be small increment or change in value of y, del y or h. Now equation 2 can be written as, then equation 2 in terms of del x and del y can be written as sine y plus h is equal to x plus k. Let this be equation 3. Now from derivative, from the definition of first principle, from definition of first principle of derivative, we can write from equation 1 the derivative of function y with respect to x is equal to the derivative of function y, that is sine inverse x with respect to x, is equal to limit k tends to 0 sine inverse x plus k minus sine inverse x whole divided by k. Let this be equation 4. So derivative of y with respect to x is equal to limit k tends to 0 sine inverse x plus k minus sine inverse x whole divided by k. This is the expression for derivative from first principle. We will be using this step in next, okay, in future. So right now okay, 2 and 3, you can write 2 and 3. What we have to do is subtract equation 2 from 3. Okay, subtracting equation 2 from 3, here we can write y plus h minus sine y is equal to x plus k minus x. Okay, or sine of y plus h minus sine of y is equal to simply x, because xx only k is remaining there, because xx is cancelled out. Now on right hand side there is h inside sine, so divide both sides by h. We get sine y plus h minus sine y whole divided by h is equal to k divided by h. Now taking limit as h tends to 0, we have h tends to 0, we have limit h tends to 0 sine y plus h minus sine y whole divided by h is equal to limit h tends to 0 k divided by h. On left hand side, using the relation sine c minus sine d is equal to 2 times sine c minus d whole 2 times cos c plus d whole 2, we get limit as tends to 0 in place of sine y plus h minus sine y, we can write 2 times sine y plus h minus y whole divided by 2 times cos y plus h plus y whole divided by 2, and whole divided by h is there, because in place of c here y plus h is there, and in place of d y is there. So using this relation in this one, we can write this one. So limit as tends to 0, k by as is there. Okay, in next line we have limit as tends to 0. We can write sine y as divided by 2, sine as divided by 2 times cos 2y plus s whole divided by 2 whole divided by s is equal to limit as tends to 0, k divided by s is there. Or now we can take out cos 2y plus s divided by 2 from this limit as cos 2y plus 0 whole divided by 2. We put s is equal to 0 inside cos here, and we are left with limit as tends to 0 sine 2 times sine s divided by 2 whole divided by s is equal to limit as tends to 0 by s is there. Again here we are left with cos y, okay, because y 2 cancel out, so y is remaining, cos y is there, and inside this limit we have to arrange value there. Okay, so in numerator I keep there sine of s by 2, and I take this 2 to here, okay, is equal to limit as tends to 0, k divided by s. Now as tends to 0, s by 2 also tends to 0, so we can replace this s tends to 0 by s by 2 tends to 0. Okay, because we have to use here limit, use here the formula as a limit sine theta divided by theta is equal to 1. We have to use this standard formula, okay, inside this limit. Okay, now or we can write cos y limits s by 2 tends to 0 sine s by 2 whole divided by sine s by 2 is equal to limits s tends to 0, k by s is there. Now this whole part becomes 1, so here cos y times 1 is there, and limit as tends to 0, k by s as it is on the right hand side. Okay, or cos y is equal to limit as tends to 0, k by s. Or let's take the reciprocal of this. Okay, reciprocal of this. By taking reciprocal of this, we can write 1 by cos y is equal to limit s by k, and here we have to change, because here when k by s is there, we have to write limit s tends to 0. But if s by k is there, then here should be k s tends to 0 should be replaced by k tends to 0 here. Okay, or we can write 1 by cos y is equal to limit k tends to 0, and in place of s what we can write here is from here, okay, from here, so y plus s is equal to sine inverse x plus k, and s is equal to sine inverse x plus k minus y, and y, the value of y from equation 1 is sine inverse x there. So using the value of x from here, we can write like sine inverse, okay, sine inverse x plus k minus sine inverse x whole divided by k. Okay, and again from equation, okay, from definition of derivative, we have limit k tends to 0 sine inverse x plus k minus sine inverse x whole divided by k is equal to dy by dx. It means derivative of y with respect to x. So in place of this one, we can write dy by dx. So cos y is equal to dy by dx, or simply we can write d sine inverse x divided by dx is there. Okay, or we can write d sine inverse x divided by dx is equal to 1 by cos y, and 1 by cos y means we can write 1 root under 1 minus sine square y, because you know sine square y plus cos square y is equal to 1, and cos square y is equal to 1 minus sine square y, and cos y is equal to 1 minus root under 1 minus sine square y. Okay, so cos y is replaced by this one here. Okay, now we have sine y square. Sine y is equal to, we have from here sine y is equal to x. So using this value we get d sine inverse x divided by dx is equal to 1 by root under 1 minus sine square y, and if we replace sine square y by x square, then we get 1 minus x square y. It means derivative of sine inverse x with respect to x is equal to 1 by root under x 1 minus x square. This is how we can find the derivative of sine inverse x with respect to x from first principle. Okay, this was in this video. Similarly, you can try finding out the derivative of y is equal to cos inverse x. Okay, please try it once. Okay, so its derivative should be d cos inverse x is equal to 1 minus 1 root under 1 minus x square. Okay,